tomorrow night, 9 p.m. until 15 p.m. And in our previous class, I have already shared with you the type of questions that will be asked during the first test. Okay. So I hope you have already watched Transformer pre-recorded video that I have already shared with you last week. Okay, and today we just maybe to discuss a little bit about this transformer, and anything that you are not clear, then you can ask me. Okay, so that pre-recorded video is part 1, where inside that video is actually just an introduction about the transformers, where the main point for that pre-recorded video is to expose the students with the equivalent circuit of the transformer. Okay, and then I think after the discussion about last week pre-recorded video, then I will leave you with another video which I have also pre-recorded and shared with you in the YouTube playlist, which is Transformer Part 2. So inside that video, okay, is actually more on the performance analysis. How can we perform? We do some testing. Okay, we do some testing where we have what called the no load test and also the short circuit test. Okay, so that test, both tests is actually used to obtain the parameters of the transformers. Okay. Okay, so without further ado, so this is the actually I want to discuss about the last week pre-recorded videos. Okay, about the transformer part 1. Okay, so as you can see here in the first figure here, the first figure at the top one. Okay, in that video I have described about a little bit about this transformer. This is actually a transformer where there is no load connected. Okay, so meaning that your V2 is disconnected to the load, which is this is actually what we call open circuit, open circuit. Okay, and I would like to remind to you all that V1 and E1 and also E2 and V2 is actually a different parameters. Okay, so V1 is actually referring to the voltage source. So this one is your V1, while E2 is the voltage induced due to the flux. Okay, due to the flux. Okay, so and E2 also is actually the voltage induced at the secondary part due to the flux. Okay, and since this is an open circuit, meaning there is no load connected, so V2 is equals to E2 for this case. Okay, E2 is equal to V2 because open circuit, the current I2 is actually 0. Okay, and we know already the relationship between the transformers parameters, where actually the function, the basic transformers, basic function of the transformer is the first one is what? What is the, there is a two basic function for the transformer. Can someone? What is the first function? The very important function. Yeah, step up or step down. Okay. Step up or down. Okay. But this one is only can be used with AC system only. So the transformer will be only function to step up or step down, but if the voltage is AC. Okay, the transformer will not function if the voltage is DC. Okay, so please bear in mind that is very important part. And the second function, what is it? Yes, isolation. Okay, isolation meaning that in terms of electrical, so if there is something happen here, short circuit or maybe lightning strike, so we can actually save this source part here. Okay. Okay. So and then we also know that relationship which is n1 n2, which is the number of turn at the primary side, and n2 is the number of turn at the secondary side. So this one is equals to E1 over E2, which is the voltage induced, and this one is equals to I1 over I2. Okay. So in this case, since I2 is 0, so your I1 will also 0. Okay. So I1, which is the primary side, is also 0. But as you can see, even though I2 is 0, there will be a small current, which is what we call IM. This is what we call the magnetization current. Okay. So even though it is open circuit, no load connected, when you connect a source, there will be a small current that going into the coil. Okay. So this small current is actually used to magnetize this core, okay, to produce the flux. Okay, so it is required to have this IM. And then if you refer to the second figure here, this is where you connected the load. The transformer will connect the load. Okay, and then as you can see right now, I2 will flowing. And since you have the I2, then at the primary side, you have I1 and also uh, the magnetization current. Okay, I hope you clear on this part. Okay, and then next is actually on the equivalent circuit. So this is actually the equivalent circuit. Okay, that for the transformers. Okay, we have R1 and X1. So this is actually represent this one is actually the internal resistance of the state of the primary winding, and X1 is the inductance, okay, the reactance values of the winding. And then we have also RC and also XM. So RC and XM, as you can see, is actually parallel with E1. Okay, RC and XM. This one is actually represent the core. So RC is actually the represent the core losses. Okay, core losses. And if you remember, there are two types of core losses. Can you name it? The first one and the second one. What is the core losses? What is the losses that associate with the we call core? Yes, hysteresis. And the second one is eddy current losses. Okay, good. Okay, so this is actually lump sum. So we represent as a resistance. And this XM is actually the reactance due to the magnetization effect. Okay, and then we have the E1, voltage induced. And then as you can see, we have I1 and I1 prime. Okay, so actually I1 is equals to I1 prime plus IO. Okay, and this IO, as you can see, is actually divided into what we call IC and also IM. So this is IM, okay, the magnetization current, and IC is actually referring to the current that's actually represent when you multiply with R, I square R represent the losses of the core. And then we have here the voltage induced, and then E2, and we have this voltage V2. Okay. So this is actually, I go fast on this one, as you remember, as you can see in the my video, YouTube video. So this is actually the phasor diagram that what I call represent the relationship between the voltage and also the current. Okay, so as you can see, we have V1 and E2, and it depends on which one that you put as a reference. Okay, so put as a reference meaning that the angle is 0. So in this just example here, so E1 is set as a reference, meaning that you start with the angle 0 here. So meaning that E1 with the angle of 0. And then as you can see here, we have I1. So I total here, I1, which is I1 is actually the combination of vectors of IC and also IM. So it will represent this IO, okay, right now. IC and IM, we produce IO and IO, and then you have a vector of I1 prime. So I1 prime plus IO, we will get I1. Okay, and I1 multiply with R1, so you will have the voltage drop, which is represented by this red line, and then I1 X1, okay, we represent this line. So the total voltage due to these vectors will be V1 here, and as you can see, there is a different angle between the voltage source and the voltage induced. Okay, so this is at the primary side, and then this one is actually at the secondary side. So as you can see, it doesn't matter. It actually depends on the which voltage that you use as a reference. Okay. So in this case, V2 is used as a reference. So this one 0. So as you can see here, we have I to R2 voltage drop, and then the voltage drop across the reactance, and the total vectors will have E2, and then as you can see, we have a voltage difference between E2 and also V2. Okay. Okay, so next is actually, okay, this is the what we call the approximation. Okay, this is actually the one that we use, okay, the one that we use for our calculation. Okay, so please bear in mind, this is the circuit that we are referring to in our after this in our calculations. Okay, so as you can see before this, R1 and X1 is actually at this side, right? Okay, but to simplify our calculation, we can shift the location of R1 and X1 after RC and XM. Why? Because in the previous research have shown that the calculation error is not very significant. Okay, it's not very significant. So that's why we allow that R1 and X1 to be shifted after RC and XM. Okay, because it will simplify all the calculations. And as you can see also R2 prime and X2 prime and also ZL prime. This is prime meaning that it has been referred to the primary side. Okay, so as you can see here, so we have two sides, right? We have primary and secondary part. Okay, so to simplify our calculation, we can refer, sorry, we can refer all the secondary part into the primary part, and you should know how to transfer the secondary part to the primary part by using this equation. Okay, so this is very important. Okay, so this is R2 prime is actually the resistor values after you have converted into you have referred to the primary side. Okay, so as you can see here, all the resistance and also the impedance. For example, Z load prime, when you refer to the primary side, use this equation. Please use this equation, meaning that A is actually A square. What is A? A is the number of turn, N1 over. So this is very important. Okay, and this is only for the impedance. As you can see, all must multiply with A square. And for the voltage, if you transfer the secondary to the primary, you need to multiply A, and for the current is actually division. Okay, So this is what I have highlighted during my pre-recorded video last week. Okay, and then what else that I want to highlight? Any okay, so this one this one A. So what is A? This one, and this is actually the physical structure of the transformer. It's not straightforward lah. Kalau macam if you see in our theory, the primary side is winding like this, secondary side, right? But in physical or in the real world, it's not like that. The winding is actually, as you can see here, the winding of the primary is actually usually at the inner side, while the secondary winding is actually at the outer side. Okay, so and as you can see, this is the core. Okay, this is the core. It can be from cast iron or so on. And as you can see, it's not a solid cast iron. It's actually laminated. It actually divided piece by piece. Okay, this is to reduce what we call the eddy current. Eddy current losses. Okay. Okay, I think that's all from my part. Okay, just a brief refresh on this transformer part 1 videos. This is actually then just an introduction about the equivalent circuit of the transformer. And in that slide also we have examples. And that example I think is sufficient enough for you to have a good understanding on this transformer part 1. Okay. And in transformer part 2, so there will be what you call test, what you call no load test and short circuit test. And at that part, there will be a lot of example and exercise. So we are more concentrated on that part of this. Okay, and I have also shared with you in our WhatsApp group the Alan Hamley book. So that one is actually, please refer to that one. Is usually I refer for this magnetic circuit and also transformers. Okay, but please be aware because not all topic, for example, in black transformers, our syllabus is not very deep. If you go to the topic of the transformer, referring to the Alan Hamley book, so Alan Hamley is quite extensive in terms of analysis of the transformer. Some of them are not covered inside our syllabus. Okay, so that's why it's quite difficult to have a fully reference textbook. Okay, that's why. So so most of the example and exercise is better to refer to the slides, okay, because the example and exercise that inside the slide has been altered, okay, has been suited to suit your syllabus. Okay, but you can use that textbook. There are also exercise. You can use that textbook for to have more exercise. Usually, you can try. We have the magnetic circuit that I haven't discussed extensively, which is the series parallel magnetic circuit. Okay, so inside that textbook, we have that kind of exercise that you can try to make use of it. Okay, and then the transformer also. Yes, you can use that, but please be careful. But because the content inside that is very quite extensive and not covered under your syllabus. Okay, I think that's all from me. Any questions? Okay, sorry. Okay, any questions? You can chat or you can on your microphone. Your test will be tomorrow. Okay, tomorrow night. And okay, for the tomorrow night, so all the submission must be in PDF. I think you all have already experienced how we do the test in UTM. So in PDF, so usually you are required to convert by using cam scanner, PDF cam scanner using your phone, and submitted it in Google Form. Okay, for my section, submit through Google Form. The other section it depends on the lecturers. Some of the lecturers use e-learning for the submissions, and but for me, I think it's better is I prefer to use Google Drive. Okay, and also there's also several forms that you need to fill up, but I'm waiting orders from the coordinator. So if if coordinator do the form for all section, then I will use that form. Okay, I think that's all. Any questions in the chat room? Yes, covers only series magnetic circuit. Okay, so I think you can use the one and stop the recording.